Hey everybody, welcome to today's Kubernetes Master Class. Really happy to have you all join us today. We have quite a few registrants for this session, so I just want to take a moment to wait while they join the line since we're just getting started. We have about 75, 90 minutes scheduled, definitely flexible depending on the questions that are asked and how quickly we move through the content. But the woman who's really going to be doing the heavy lifting today is a principal software engineer, Prachi. Prachi, are you there?
Hi everyone.
Hey, Prachi. Okay, awesome. So I'll let Prachi introduce herself a little bit more as we go. One other thing I wanted to point out is that if you do have questions, like follow-up questions, or you're looking for a resource or something like that, please don't hesitate to reach out. You can reach us at this online training at rancher.com email. And we're happy to keep the conversation going. So as I said, we have about 75, 90 minutes scheduled. These really vary just depending on how many questions you all have. Please do ask your questions. We want this to be as responsive to what you all want to learn as possible. Just use the chat questions tab and go to webinar. It's really easy, and we'll see your questions in the chat as they come in. We do have a couple moments during the presentation where we'll pause and take questions, but we'll mainly answer them aloud at the end. And so for whatever reason you want your question to be private, just mark it so, let us know in the chat. Otherwise, we'll answer it aloud for everyone's benefit. And if you do have questions, please do put them in the chat now so that we can respond as we go. As I mentioned, the session is being recorded. We post all of our online trainings, online meetups, master class. We do a ton of online education, and we post it all on YouTube, so it's free. You can just find it on Rancher's YouTube channel. And there is a huge community around Rancher technologies, around Kubernetes. So if you have more questions, you want to get involved, please do join the Rancher Slack, which is slack.rancher.io. There's thousands of members and hundreds of people asking and answering questions every day, including Rancher engineers and our colleagues, who check those questions that are there and do their best to answer. If for whatever reason you want more masterclass files or heads up about the masterclasses, then you can join the masterclass channel. It's just pound masterclass, and we'll post extra information there. And as I mentioned, we do have a slew of online trainings. So we do a intro to Rancher and Kubernetes training every week. I will talk a moment before I hand this off to Prachi about Rancher. But if you are new to Rancher, I highly recommend you join the intro training. It's every week. It's free. It's live, just like this. There's a Rancher engineer on to give you a demonstration of Rancher, show you how to spin up Kubernetes, and the value that Rancher adds on top of it. And we talk about Kubernetes components, Kubernetes architecture. What is the point of Kubernetes? And then what does Rancher do on top of that? So it's a great training, highly recommend it. And then we also have another advanced class this week where we will talk about the new CIS scanning tool in Rancher. That has been out for a little while, but Rancher 2.4 just went GA a few weeks ago, and so our senior director of product, Bill Maxwell, will be on going through the CIS scanning tool, which will help you see if your Kubernetes clusters are living up to the benchmarks of security that they need to adhere to. So with that out of the way, I just want to give a really quick kind of overview of the Rancher ecosystem and what Rancher the company and Rancher the flagship product, the Rancher Management Server. So we have a lot of products and projects. Our products are supported by our support licenses, but everything listed here is totally free. It's completely open source. There's no hidden features, nothing like that. But when you hear Rancher, Rancher is the company that creates Rancher Management Server, which Prachi will be walking us through. But we also have RKE, which is certified Kubernetes distribution that works for your database. For on-prem, we have a lot of other products and projects that we're coming out with that you can check out. And so just to take a step back really quick, there are kind of two main pillars to understanding Kubernetes success. So the first is having the ability to do compute wherever you need it, right? If it's on-prem, on your desktop, on the edge. And so in order to do that, you need a certified Kubernetes distribution. So Rancher offers, RKE, which I just mentioned a moment ago, but Rancher Management Server also works with EKS, AKS, GKE, any other, certified Kubernetes distribution. And then for edge situations like development on a laptop or a branch station or, edge situations where resources are limited, we offer K3S, which is another lightweight certified distribution. So that's one of the pillars, is being able to have your compute everywhere. And then the other is a centralized management plane. And that centralized management plane allows you to actually use a platform instead of working on your platform. So you get from that shared tools and services, security and authentication, cluster provisioning, cluster operations, upgrading, and all that sort of stuff. So, this is and that is what Rancher does. It has all of those built in. And so this is a super fast introduction to what Rancher Server is. Prachi will go through it more, and we'll see a live demo of Rancher. But if you are brand new to Rancher Server, I highly recommend you take that intro training, that I mentioned before, because it helps both the IT ops, those people who are interested in control, maintaining Kubernetes, provisioning new clusters, things like that, and then also the DevOps teams who are going to be actually using the provision services for their build, deploy, and management of their applications. So that's what Rancher offers for both of those team members, the IT ops and the DevOps. So with that out of the way, super fast introduction of the Rancher landscape, I'm going to go ahead and pass this presentation off to you, Prachi.
Hi, welcome everyone to today's masterclass, which is about OPA Gatekeeper support in Rancher. My name is Prachi Damle. I'm one of the principal engineers at Rancher Labs. I work on the Rancher's central managed Kubernetes management platform. And today we will dive into the latest feature which was released with Rancher 2.4 release, OPA Gatekeeper support. So this is the agenda of the things that we will go on today. So to start with, we will just touch base upon the need of having OPA and policy enforcement, and what is OPA and Gatekeeper project. Then we will dive a little bit more into Gatekeeper details. What are constraints? What are constraint templates? What are examples of policies that Gatekeeper offers, and how to enforce them? Then we will hop on to Rancher, how it integrates with Gatekeeper, how we can enable Gatekeeper with Rancher, and apply policies to the Rancher clusters, Kubernetes clusters. So a demo and walkthrough of this integration will follow, and we'll be happy to answer any questions that come along. So let's get started. So enforcing security guidelines. Organizations across the board often need to secure their environments, and a way to do that is define security policies and make sure that their systems are compliant to these policies. So we all know that admins always need to prohibit users from accessing resources across projects or accessing resources that they are not authorized to use. Or we want to allow users belonging to certain teams to provision and configure new setups, but not all users should have that ability to do so. Also, for Kubernetes, when users are given access to the clusters, they can deploy anything in the cluster, and ops definitely don't want all users to be able to deploy any workload on the Kubernetes clusters. So there is a need to define policies to say this, apply some resource limits for the workloads that users are deploying, or also some policies like allow only the images to be deployed from a specific repository. So how can IT ops or admin do this policy definition and decision making in an automated way. There is always need to do all this definition in an automated way so that the policy definition and application is done in a consistent manner. So policy engines like OPA help to ensure consistency and compliance with respect to security policies. What is OPA? OPA is Open Policy Agent. It is an open source and general purpose policy engine. It is a CNCF open source project. It provides a high-level declarative language, which is called as the RIGO language, and it lets you specify policy as code using this language. Now, it is highly general purpose engine, so it can be used to enforce policies in various software systems. It could be used for microservices, Kubernetes systems, CI/CD pipelines, API gateways, and much more. OPA provides simple REST APIs to offload the policy decision making from your internal service. So your service need not worry about how to define and decide on whether a particular request is compliant to a policy or not. That job is offloaded to OPA when your service integrates with OPA. So policy decision making is decoupled from policy enforcement using OPA integration. So for example, if you have a service, if you are running an application and a request or an event comes up to your service, if you want to check if your service wants to let this request go through only if it is compliant to certain policies or if it passes all checks, then all these policies or checks can be defined in the Open Policy Agent engine, and your service can then place a REST API call or a query to this OPA engine, and OPA engine will then refer to the policy which is defined in it, use the data from your service to make sure that the current request is according to the policy or compliant to the policy that is defined, and respond back with a decision, which your service accordingly can read and either let the request go through or deny it. Thus, the policy decoupling is done, or policy decision decoupling is done using OPA. Then what is OPA Gatekeeper? So Gatekeeper is one implementation of the OPA paradigm. So Gatekeeper project provides integration between OPA engine and Kubernetes. So it is an implementation available for Kubernetes clusters. How does a Gatekeeper do this? Gatekeeper uses the Kubernetes validating admission webhook concept. So it gets installed as a validating admission webhook controller. Admission controllers in Kubernetes are always called whenever any request is made to the API server. So whenever a Kubernetes create, read, update, or delete request is invoked by any client, before it reaches the Kubernetes API server, it has to go through all the validating admission webhook controller to make sure that the request can pass through. So when Gatekeeper is installed at such an admission controller, when it receives the request, it is going to use OPA engine to make sure that this request is compliant to any of the policies that have been set for the Kubernetes cluster. If the request is not compliant according to any policy, then it denies the request and it does not even reach the Kubernetes API server. Using this Gatekeeper, thus admins can make sure that your clusters stay compliant to policies and are protected. How does Gatekeeper do this? Gatekeeper uses native Kubernetes custom resource definitions, or CRDs, for instantiating the policy library, or which is known as constraints, and for extending the policy library. So constraint templates and constraints are two concepts or two CRDs that Gatekeeper introduces. So when you install Gatekeeper, it installs or registers the Kubernetes CRD called as Constraint Template. And we will dive into what a template is and what a constraint is soon. Gatekeeper itself provides an extensible policy library, parameterized policy library. So it has already on its GitHub repo. So Gatekeeper project can be reached on GitHub on the link that I have provided here, and it itself has quite a number of policies, definitions, or constraint templates available for use. And this policy library can be used when Gatekeeper is installed, and these constraint templates can be defined in your cluster. Another important feature of Gatekeeper is audit functionality. So it supports auditing of existing resources of your Kubernetes clusters. So once you define a policy, and if you enforce that policy, Gatekeeper on a periodic basis runs this audit functionality and checks if any of the existing resources of your clusters are violating this defined policy. If they are, then Gatekeeper puts them as in the violations or the number of violations for that constraint. Using this, the cluster configuration management can be achieved. So your any ongoing CRUD request, create request or update or delete request coming to your cluster can be denied by defining the policy. But if there are existing resources in your cluster, Gatekeeper also helps to find them out, and thus admins can then go and correct wherever the policy is not being followed. So about the Gatekeeper policy library, these are few of the examples that are available in the library. For example, allowed repositories. This policy makes sure that only images from the repositories that you want can be used for deploying pods. Container limits, for example, if you want to set particular resource limits on containers, you can use this policy so that any container that is being deployed in the Kubernetes cluster will have to follow these limits. Otherwise, the launch of the pod or the container will be denied. Required labels. This requires resources that you specify in the policy to be created with the labels that you specify. So if any resource which is not having the labels that an admin wants, it won't be allowed to be created. And pod security policies. It lets you define policies on pods. So when we are coming on to pod security policies, what happens to the PSPs that we already know of? So PSPs continue to exist, but as we know, pod security policies are specific or apply to pods only, while Gatekeeper can be configured on a wide number of resources, Kubernetes resources in the cluster. Gatekeeper library has a set of constraints and constraint templates which are based on common pod security policies. So here is a chart that Gatekeeper repo has published. For all the known PSPs, pod security policies, there is an equivalent Gatekeeper constraint and constraint template that is available in the Gatekeeper library. With this, we can deep dive a little bit into the Gatekeeper constraint and constraint template concepts. So Gatekeeper constraint template is a native Kubernetes CRD or custom resource definition. You define a constraint template for the policy you want to enforce. So a template defines the actual policy logic using the Rego language, which the Open Policy Agent engine is going to execute. And it also defines the schema for the policy or the constraint. So the Gatekeeper constraint template is nothing like a function definition where you are defining the function's logic and the function's parameters. And you can create these constraint templates using YAML definitions. So you just do kubectl apply and your constraint template YAML to create this constraint template or template definitions. So Gatekeeper Constraint, on the other hand, is an instance of the Constraint Template. So using a template, you are defining the policy, and using the constraint, you are applying that policy to specific resources. And you have to also provide the parameters to the policy definition or the template definition in a constraint. So constraint specifies the function parameters for the constraint templates logic, and it defines the scope of objects the policy applies to. For example, if you take the policy or the constraint template that Gatekeeper library has, which says that Kubernetes objects require certain set of labels. So the template will just have the logic which says that object of certain kind require labels of certain set or provided labels. And the Gatekeeper constraint will say that all pods require the labels foo and bar. So whenever the constraint is enforced or enabled, any pod which is coming up in the cluster will need to have these two labels. So constraint template is the definition, and constraint is the actual instance of the policy, which is narrowing down on certain set of Kubernetes resources. The same template can also be then instantiated to create a policy saying that any namespace that is created in my cluster needs to have the label ABC. So this uses the same constraint template, but then it applies the policy for namespaces. So how does the constraint do this? The constraint consists of certain fields called as kind, which is points to the constraint template which it is using, then the name of the constraint, and using the match parameter, you can define the scope of objects to which your policy is applying to. And using the parameters, you provide the parameters that your constraint template is expecting. There's another field in the Gatekeeper constraint, which is enforcement action. And there are two values, deny and dry run. By default, the value is deny. It means that whenever you create a Gatekeeper constraint, it is enforced by default. So any resources or any request that is coming up to your cluster is going to be validated against this constraint. And if it doesn't meet the constraint, then the request will be denied. There's another value for enforcement action, which is dry run, which you can use to test your policies or definitions or your constraints. Using dry run, Gatekeeper won't deny the request which is not following the policy, but it will basically just record it. This constraint has been violated by this request. Now, integration of OPA Gatekeeper in Rancher. So this powerful tool, which can be used to define policies in a generic way and apply them to Kubernetes clusters, has been introduced or integrated with Rancher 2.4 release. This feature is experimental right now in Rancher 2.4 line. And the reason for that is Gatekeeper project itself is currently in beta. Rancher has also introduced a new dashboard view, which I'll demo soon. So Rancher dashboard view provides the ability to enable OPA Gatekeeper in the user's Kubernetes cluster. Now, enabling OPA Gatekeeper can be done only by global admins or cluster owners, cluster admins. OPA Gatekeeper can be enabled for all clusters. This is not specifically applicable to RKE clusters. You can enable OPA Gatekeeper in all clusters. OPA Gatekeeper is deployed as a Helm chart, and it has been added to Rancher's system chart. So it deploys as an app on your Kubernetes cluster. Along with the OPA Gatekeeper, the Rancher system chart also installs a couple of built-in policy definitions or constraint templates from Gatekeeper's library. So when you install Gatekeeper, two of these constraint templates from the library are already installed in your cluster. for creating policies. One is whitelisting image repositories, and the other is enforcing labels on Kubernetes resources. So I'll demo these constraint templates soon. Now, Rancher's dashboard view displays also any policy violations that have been reported by Gatekeeper's audit functionality. So if you enable a certain policy and if any resources in your cluster are already not compliant with that policy, these violations will be reported on Rancher's dashboard, which the admins can view and then accordingly correct those resources. Now, as we have seen in the constraint template and constraint definitions, it is quite complex to define a constraint template. One also needs a specialized skill of knowing Rego language. So Rancher provides a very convenient form to create new constraint definitions, constraint templates and constraints. So Rancher's integration is helping you to define gatekeeper policies. So with this, I can demo the Gatekeeper integration. Before that, Matthew, are there any questions that I can help answer?
Yeah, thanks, Prachi. That was awesome. So well organized and clear. I really appreciate the slides and explanation. So there's one question. This is from Stefan, who asks, I understand that he says, I understand that Gatekeeper with Rancher is in beta. Is OPA itself also in beta?
Yes, OPA Gatekeeper itself is also in beta. That's why it is experimental feature of Rancher as well.
Okay, cool. Awesome. Thank you. That is surprisingly the only question that has been asked. So please do continue with your demo, and I'll just remind everybody that if you do have questions, please do put them into your chat so we can help answer.
Awesome. All right, let's hop on to our demo. Okay, so here I have the Rancher's Kubernetes management platform. And right now I'm at the global view. I have few clusters that I have created using the DigitalOcean nodes. Now, in order to go and enable OPA Gatekeeper, one will have to drill down to a particular cluster. And now with Rancher 2.2.42 or 2.4 release, you will be having this try dashboard button over here on the right hand side corner. So once you launch the dashboard for your cluster, this is a new UI that has been introduced with 2.4. With this, you will see on the left-hand side menu, there is an OPA Gatekeeper option available for your cluster. Now, I already have Gatekeeper enabled. Let me go on to the other cluster. So if you don't have Gatekeeper enabled in your cluster, you will land on this page. You can go and enable OPA Gatekeeper from here. If this will use the defaults of the Rancher system chart. If you want to customize the values and want to deploy OPA Gatekeeper such that, for example, the audit runs at a different periodic interval, by default it runs every 5 minutes. Or if you want to list more than 20 violations of your constraint, these parameters can be configured while you are enabling OPA Gatekeeper. So once you enable Gatekeeper, first and foremost, what you will see is what are the parameters that you have launched with the Gatekeeper tool with. And then you will also see in the left-hand side menu, two tabs, Template and Constraint. So this template is Constraint Templates that you will be creating, an admin will be creating to define new policies. Once Gatekeeper is installed, Rancher also installs two Constraint Templates by default. One is to whitelist the repositories, and the other one is to specify certain labels are required on certain Kubernetes resources. One can view the details of a particular constraint template by clicking on the constraint template name. What this opens up is the YAML definition of the constraint template. So this constraint template, as we glossed over before, contains two things essentially. One is the schema, which defines what is the type of the parameters, what are the parameters and what are their types. For example, this constraint template takes in a parameter called as repos, which is nothing but list of the repositories that you want to whitelist. And then it also contains the Rego language, which is a different language or specialized language, which you should be using to define your policy and define the logic of your policy. Using this Rego language, it is also possible to go and customize the error message that OPA Gatekeeper will be presenting if certain request is not compliant to your policy. Now, this field, status field, is important because this is a constraint template. But if you hop on to the constraint part, constraints are basically the policies that you have enabled by using the templates. So for example, I have created one definition of constraint, which uses the template Kubernetes allowed repos. So in order to create a constraint, Rancher's dashboard provides this useful form. So in order to create a constraint, either you can provide a YAML definition of your constraint, or you can use this form to create one. You provide name to the constraint. You choose which constraint template is your constraint instantiating or defining. And then you can add all the parameters that your constraint template requires. So you can add, say, my constraint template requires the reports parameter. So I'll put all the list of repositories in this form. Then using the form, you can also toggle whether you want this enforcement action or as deny or dry run, whether you want this constraint to be just installed as a test run, or you want to fully and finally apply this policy on your cluster such that it will start denying any request that is not compliant. Now, this is an important field which lets you define your policy for the resources that you want. So using the match field, you can specify that I want to apply this policy only to a particular namespace. And also, I want to exclude all the namespaces that I want. By default, Rancher excludes all the system namespaces from your constraint so that you don't interfere with any system functionalities. Then using the selectors, these are the label selector and namespace selector, which are the standard Kubernetes selectors. You can specify or narrow down the scope of resources to which this constraint applies. And then kinds, you can lets you specify the API groups, where you can say that for API group, I want to basically apply this constraint for pod resources. So using this form, you can define a gatekeeper constraint. The other way, of course, is if you already have a constraint YAML, then you can just paste the YAML in here and create a constraint. So the constraint that I have already created, let us go over that. So this is of type the allowed repos constraint template, which is for whitelisting the repositories. Now, if you check the YAML definition of this constraint, then we can see that what it is doing is it's excluding all the system namespaces. And this constraint only applies to pods. If I wanted to apply it to any other resource, I would specify that in the kinds. But Kubernetes allowed repositories or whitelisting repositories is like launching pods of a certain repository from a certain repository only. So it applies to pods. And then I'm also narrowing down the scope of this policy to two namespaces. One is production and one is, say, another NS. So any other namespace in which a pod is coming up, for that namespace, this constraint will not be applied. Then I specify the parameters of this constraint. So as we had seen in the template, it takes in a list of repositories from which pods from which images from which will only be allowed for the pods coming up. Now, next is the status field, which is important. Whenever Gatekeeper is going to run its audit functionality, it is going to report any violations that it found in the status field of a constraint. So it will show the timestamp or the time at which the Gatekeeper audit functionality last run. And it will report the total number of violations that Gatekeeper found. And it will also report the particular resource which is not compliant to this constraint. For example, I already had an app or a pod which was running in one of these namespaces, which was using some image other than the quay.io repository. So Gatekeeper does provide a message saying that this particular container has an invalid image repository. So this is the place where Gatekeeper goes on reporting all the violations of existing resources in your cluster. Now, Rancher also lists all these violations on the OPA Gatekeeper dashboard. So you don't have to drill down to each and every constraint and find out what are the violations of the constraint. In the details of each constraint, we do already report these or show these violations, but all the violations are also listed on the homepage of Gatekeeper within Rancher for a quick look. So using this, admins can go and figure out what resources are not following the policy and go and fix that. So for example, let's demo this template that the constraint that I have applied, which is query only. For example, let's go back to Rancher to deploy a pod in the namespace that we defined this constraint for. So the back to Rancher link on the dashboard view will take back to the Rancher's standard UI. In here, on this cluster, I have enabled Gatekeeper. And if I try to deploy any application, say I'm trying to deploy a workload in this namespace production, and I'm not using the repository qa.io, and try to launch this workload, then Gatekeeper is basically going to deny this creation of workload, and it does give the error message saying that the request is denied because you are using an invalid image repository. And allowed repositories, it will print out all the list of repositories that are allowed by your policy. Now, if I already had some resource present in my cluster, for example, I already have this another app which is present in this namespace another NS, or we can go and actually deploy a new workload. And we can say add this to a new namespace. Now, when I launch this workload, Rancher is going to create this namespace and is also going to go and launch this pod. Now, launching this workload went through and was allowed because the Gatekeeper constraint or the policy was not applied on this new namespace that I just created. So let me go and edit the constraint that we have defined to also cover this particular namespace, new NS. So let's go back to the dashboard. And under OPA Gatekeeper, I'm listing the constraint that I have already created. Now I want to go and edit this using the form. So I do on the top right corner, use edit as form. And I want to apply this policy also to the new namespace that just got created. So I add this to the list of namespaces and save the constraint. Now let's go back to Rancher. Once you apply this constraint to the new namespace, you can see that the existing app which we deployed to this namespace is not touched. So it continues to run. Gatekeeper does not halt them, or it does not block their the existing applications. But if I try to deploy any other application and this new namespace, which we now added to our constraint, Gatekeeper will start denying this request, which our constraint is now looking at this namespace as well. Now, whenever Gatekeeper audit functionality is going to run, it runs every 5 minutes. So next time when it runs, it is going to figure out that there is an existing application or workload present in this namespace, which is not using the repository that we want. And this should come up as a policy violation on the dashboard view. So let's see if that is listed as a violation. If Gatekeeper, so it is not yet seen in the list of violations. So probably the Gatekeeper's audit has not yet run. But if when it runs, it will be listed under the violations here, and you should see another entry for the existing application that we had launched. And once the violation is figured out, it will also be listed in the template, in the constraints details, as well as you can go and see in the YAML that there will be another violations reported here. So this is how you would enable Gatekeeper in Rancher and define constraints using either the built-in templates, or admin can also create new custom constraint template definitions. They're using the YAML view, or create as YAML form on the dashboard view. With that, we come to the end of the Gatekeeper demo. Matthew, are there any questions that I could answer?
Yeah, awesome, Prachi. Thank you so much for just seamlessly going through that. That was so great. So yeah, there are questions. Let's go through these. Okay, so here is the first one. This is from Connor, who says, so in effect, the constraint templates define, for example, the labels and tags, and the gatekeeper constraint define the scope enforcement of that constraint template.
Yeah, that's exactly right. So template is defining your policy in an abstract manner, and using the constraint, you are actually applying that policy to, or defining the scope of that policy.
Awesome, perfect. Okay, great. Okay, here's the next one. This is from Nico, who says, will Gatekeeper block an update in an existing app afterwards?
No, so existing applications continue to run. It will not affect or block the run of your existing pods or applications. It will just report that this application is not compliant to this constraint. And it is a report only feature of Gatekeeper. It is not going to stop or halt that application.
Okay, cool. Thank you. All right, this is the next one from Abid, who says, what will be the output of security scan? Is it scan policies or vulnerabilities?
So security scan is another, this Gatekeeper security scan is going to output the violations of the policies that you have defined. So it is a periodic scan that Gatekeeper runs on your Kubernetes resources. There are two modes in which it does. Either it connects to your Kubernetes API server and it lists all the resources by making call to the API server, or there is also another mode is auditing using cache. By default, that is false in Rancher. So when it is using the cache, Gatekeeper caches all the Kubernetes resources that it syncs from the Kubernetes API server. And using this cache, it goes over these resources and figures out which resources are not compliant to which constraints that have been set. But by default, this is off. And this functionality is then run, or the scan is then run by directly connecting to the API server and figuring out which resources are not compliant. So the end result of the output of the scan is going to be a list of violations per constraint. So each constraint will have its violations reported by Gatekeeper in the status field, and it will tell which particular resource is not compliant for the particular constraint.
Super cool. Okay, thank you. Great report. All right, so here's the next one. This is from Nilesh, who says, could you clarify the pros and cons of Gatekeeper versus ops-istio-plugin?
So unfortunately, actually, I am not familiar with the plugin, Istio plugin, but I will be happy to, if you could post this on the user Slack for Rancher, we will be happy to provide you more details. And I'll be happy to also dig up a few details for that.
Okay, sweet. Thanks, Prachi. Actually, this is another kind of follow-up question by the same person, Nilesh, comparing OPA Gatekeeper. So he says, what would be the advantage of using OPA Gatekeeper versus service mesh, a service mesh like Istio Linkerd using Mixer?
Right. I think that comes up in the same category.
Okay, cool. All right, let's go on to the next one. This is from Harry, who asks, can OPA Gatekeeper serve the same functionality as network policies?
So Gatekeeper is actually for a wide number of resources. It can be used. It can be used for various Kubernetes resources. It does not apply to specific resource. For example, like pod security policies apply to only pods. Gatekeeper can be used to implement all those, but it can be also used to implement other resources. So I think not exactly as network policies, but some portion of that can definitely be implemented at Gatekeeper, but it only is acting as an admission controller of API requests. So whatever requests or pods are coming up can be gated using this Gatekeeper, but I think using all the nuances of network policies may not be possible using Gatekeeper policy.
Okay, cool, makes sense. Okay, here's the next one. This is from Dominique. So this is following up on the question about a pod violating a policy versus being stopping run by Gatekeeper. So he says, if a pod is already deployed before you define a new policy, then the pod violates the policy. But since the pod is already running, Gatekeeper won't stop it. But then the pod gets rescheduled to another node. In that case, would Gatekeeper allow the pod to run, or would it deny it this time?
So whenever you are redeploying the pod, you basically, if your Gatekeeper policies has been narrowed down to the particular your scope does encompass that namespace, then yes, it will be denied the next time. But if it is still within the namespace, it is just moving the nodes and the backend, and I don't think Gatekeeper will deny. It's just that what scope you can define in the policy. If your redeployment does fall into that scope, then that request will be denied or gated. But I think just moving across the nodes, if it's still within the namespace, it should. If it is compliant to the policy, it will be fine. If it is not, it will be gated.
I see. Okay, thank you. Okay, here's the next one. This is from Connor, who says, so can Gatekeeper look at, for example, what user a pod is running with an elevated privilege? Where can we find these other types of security checks that we could look for?
So using pod security policies, you can define that a certain pod cannot have certain privileges using gatekeeper constraint templates. For example, on Gatekeeper project, there is a library that it comes up with, and it has implemented most of the pod security policies using gatekeeper constraint and constraint templates. So using the allow privilege escalation policy, I think you should be able to figure out, go and define what particular privileges are allowed. And if you install this constraint template on Rancher, whenever Gatekeeper is going and create a constraint for that as well, whenever Gatekeeper runs an audit functionality, it will report all the pods which are violating this particular definition under the list of violations on the dashboard view. So you will have to define what particular privilege escalation policy you want to set, and then whenever the audit runs, it will show all the pods that are not compliant to that.
Okay, sweet. Thanks, Prachi. Okay, a few more questions are in the chat. This next one's from Ovidio, who says, I'm looking to integrate OPA with Graphios. I'm not sure how to pronounce that, Graphios. Is there any ongoing work pursued by Rancher at this stage on that topic?
No, we are not pursuing that integration as such. We are pursuing just integrating Gatekeeper into Rancher. As Gatekeeper is progressing through its beta releases and GAing, we will be updating Rancher's integration with Gatekeeper as well. Whenever Gatekeeper comes up with, for example, I think there is currently Gatekeeper is being implemented as the validating admission controller, but in pipeline there is the feature of implementing Gatekeeper as a mutating webhook controller as well. So whenever those features come up with Gatekeeper in the Gatekeeper releases, Rancher's integration will also be updated to encompass those. But we are not, at least I don't think that we are pursuing any other integration other than this.
Okay, cool, thank you. Okay, a couple more. This one's from Nadir, who says, I'm using Kubernetes clusters created with RKE out of Rancher and then imported to Rancher. Can I activate Gatekeeper in this setup?
Yes, so Gatekeeper is not limited to clusters which are provisioned using the Rancher UI. If you have imported clusters, you can go to the dashboard UI and drill down to your particular cluster and enable Gatekeeper. So it's not limited to any particular cluster type.
Okay, cool. Okay, here's the next one. This is from Srikanth, who says, are we able to write our own custom constraint templates using the dashboard? Does it provide any way to test the policy before applying?
Yeah, so using the constraint template dashboard view here, you can create your own custom templates. Here, currently, we only have the YAML view, or we only accept the YAML input in order to create your constraint template. But you can create your constraint template and your Rego logic and paste the YAML file in here. That will install the template on your cluster. And once that is done, you can add a constraint for that template using the form and that the Rancher's dashboard has provided, or you can also define your YAML and just paste it into the edit as YAML view and define that constraint. Once you define the constraint, if you just want to do a test run, make sure that you select the dry run option of that constraint. So if this dry run is selected, Gatekeeper will only report whatever resources are not compliant to your constraint, but it will not deny those requests. So it will be like a test run of your constraint.
Perfect. Okay, awesome. Thanks, Prachi. I don't see any other questions in the chat, so I assume that we could wrap it up there. Is there anything else you want to show us before we end?
Yeah. So I think I just wanted to show that Gatekeeper basically ran the next audit poll, and the existing application that we already had in the namespace, which was not using an image from the repository that we specified in our constraint, has now been reported as a violation. So you can see on the Gatekeeper dashboard in Rancher that the name of the pod which is violating your constraint, and as well as the message that Gatekeeper has reported. So this is the only thing that I wanted to demo, Matthew, because it was remaining.
Yeah, perfect. Okay, makes sense. All right, awesome. So that was all I had. And Prachi, you're good. There's nothing else you want to show, right?
Yeah, I'm good. I think this is the OPA Gatekeeper integration so far with Rancher 2.4 release. With the upcoming releases, we will be adding more features to Gatekeeper as they get released in Gatekeeper as well.
Oh, so cool. Okay, awesome. So yeah, everyone, if you do want to get started with using Gatekeeper, I mean, you will need to get started with Rancher if you're not already. So I highly recommend the best place to start is with the online training. We have it this Thursday. It's also free and live, just like this, live demo and Q&A. This is a great way to get started with Rancher and then Gatekeeper. I want to thank Prachi again for the hard work with this demo, with the slides, with bringing this feature to Rancher as well. So rock on, Prachi. Well done. Thank you so much.
Thank you,
And I
Matthew.
guess it looks like you're showing, yeah, it looks like you're showing the docs as well.
Yeah. So on Rancher docs, we also have a new page for OPA Gatekeeper, which uh, describes all the functionality that has been enabled in Rancher, how to enable Gatekeeper and create constraint templates and creating constraint. And also it has an important note that I would like to gloss over is whenever you are defining your own constraints, just make sure that you are exempting Rancher system namespaces from these constraints, or even Kubernetes kube system namespace, because you don't want your constraint to go and block any important system functionalities. Gatekeeper constraints apply cluster-wide, and it is a very powerful tool which can actually block some of the important features of your cluster. So when you are creating constraints, it is a good idea to only apply those constraints to particular namespaces, or even do a dry run before enforcing those constraints, so that you are sure that none of the other systems of your Kubernetes clusters are affected. And then the documentation also goes over how about the audit and violations of your cluster and how to disable it as well. We also have new content coming up on this page, and in that content we will be having a write-up about a particular constraint template and how to create a constraint, and it will be about the default constraints that Rancher installs. So stay tuned with this documentation, as we will be adding more details to it as we add new features.
Super cool. Okay, awesome. I'll make sure that docs page gets in with the slides and the YouTube page. Fantastic stuff. So again, what a great launch of a new feature with lots of documentation and this walkthrough. So again, thanks to everybody for your participation, your questions. Like I said, this session was recorded, so we will post this on YouTube and email it out to you all along with the slides. Prachi, once again, lots of people saying thank you for the presentation and for the class. So well done. And I hope you have a great week.
Thank you, everyone.
All right, bye everybody.
Bye.